Hello, and welcome to Stars, Cells, and God, the show where we discuss new discoveries taking place at the frontiers of science that have theological and philosophical implications, as well as new discoveries that point to the reality of God's existence. My name is Hugh Ross, and today I'll be your guide as we explore the topic of, you're going to be talking, Fuz, about
the sixth great mass extinction.
The sixth great mass extinction. Wow. Subject dear to my heart. Now I'm going to be talking about the most abundant stars in the universe and what they mean. So, but before we get into this discussion, I wanted to encourage you to subscribe to our Reasons to Believe YouTube channel and click on the bell icon so that you can be informed of our new videos. Learn more at reasons.org or by following us on social media at RTB_official. So, Fuz, let's begin with the discovery you want to talk about, the sixth mass extinction.
Yes.
Why don't you tell us about the first five?
Yeah. Well, before we do that, I just thought it would be, to set the stage, a little bit of fun to look at a survey that was published in 2022 by Chapman University. And it's in fact, it's a yearly survey that they publish every October, kind of in honor of Halloween. You know, what are the fears that Americans struggle with? And they've been doing this now for 9 years, so this will be the 10th year when they published this survey. But in 2022, these were the top 10.
The top 10. Okay.
Yeah. And so, you know, number one is actually interesting about corrupt government officials, which is shocking that here in America. But other things make sense. You know, you can see the influence of the war in Ukraine on the data. Obviously, people are concerned about loved ones becoming seriously ill or dying. You know, a lot of that makes sense. There's actually very little about the environment in this top 10 list, which is something.
Number 9, I see, but that's pretty far down the list.
Yeah, and it's concern about the quality of drinking water, or, you know, concern about pollution in the oceans. There's really not much in there about climate change, which is interesting to me. But there's something that even people that are concerned about climate change and see that as something to be quite frightened about, there's something that I think most people overlook that, according to ecologists, may even be more concerning than climate change.
So an even bigger crisis.
Right. And that's what's called now the sixth great mass extinction, or the Holocene extinction, or the Anthropocene extinction. Those are different names given to it. But the idea here is that when you look at the baseline species loss that you can infer from the fossil record, let's say 1 million years before humans appear on Earth, to get baseline extinction rates. And then you look at the loss of species, particularly since the Industrial Revolution. What we're seeing are numbers that are well above the baseline, depending on the species, somewhere between 100 to 1,000 times the extinction rate relative to baseline. And that rate of extinction is accelerating over the last 200 years. And this is alarming to ecologists, because the thought is about 25% of plant and animal species on Earth today are vulnerable to extinction. And if those creatures where those organisms go extinct, that's going to lead to restructuring of ecosystems, which now means those remaining organisms become vulnerable to extinction. And so you end up getting a vicious cycle where extinction begets extinction.
Especially when you knock out the keystone species that other species depend upon.
Yes. Yeah. And sometimes the keystone species can be relatively small in number, or you might not even know that a species is a keystone species. So it's not always easy to predict which species is a keystone species, which makes it even more concerning. Well, the reason why this is now considered frightening to ecologists is because if you start seeing ecosystem collapse around the world and you start seeing large-scale species loss, that's going to actually impact our capacity for human civilization, because ecosystems provide critical services that are necessary for humans to flourish. It's the source of fresh water. Healthy ecosystems help to maintain climatic stability. They provide the pollinators that pollinate agricultural crops. They provide the means to control insect numbers, which are not only agricultural pests, but they're vectors for diseases. Healthy ecosystems also control the numbers of small mammals, rodents, and things like that are also disease vectors and, again, are pests and nuisance. And so if you start losing ecosystems, then it's going to create a world where human civilization may not be possible, and it could happen very quickly.
I think what's especially alarming, Fuz, is that they were having the greatest impact on mammals and birds.
Mm-hmm.
And
yes.
These are the creatures we most critically depend upon.
Yes. Birds and mammals are particularly susceptible to extinction. It may be that also reptiles and amphibians are as well. I'm not certain that the number, that people are confident in the data, that where many people feel like we may be underrepresenting the threat to amphibians and to reptiles.
Well, what I've heard about mammals is that before humans, there were more than 8,000 mammal species on Earth.
Yeah.
There's now only 4,000.
Yep.
So half of them are gone.
Yep.
So.
Yeah, well, and you mentioned earlier, the 5 great mass extinctions. Mass extinctions happen, but there's 5 of them that are labeled as great mass extinctions in Earth's history, and these are shown here on the slide. We don't need to get into the details, but these events led to a loss of 70 to 95% of plant and animal species on the planet. They were all caused by some kind of cataclysmic event, which makes the 6th great mass extinction that we are on the cusp of entering into unique in that it's triggered by human activity. Are the growing number of humans on planet Earth, that growing population is encroaching upon the habitats. We also are causing damage to the climate, damage to the environment, right? We're converting, rainforest into cropland and for agricultural purposes. All of this is contributing to the mass extinction. And it's to some degree foreshadowed by the Quaternary extinction, where when humans began to migrate around the world, going into Australia and into the Americas, we triggered the extinction of large mammals.
Right.
And so that was just a foreshadowing of what's happening now with the 6th great mass extinction. So anyway, all that wonderful,
encouraging news.
Yeah. Well, the problem, it may even be far worse than what's being depicted, because everybody's been looking at this phenomena at the species level. And so a paper was just published in the Proceedings of the National Academy of Sciences, where these researchers were looking at what is the level of loss at the genera level, right? And so now they're looking at a genus level, not the species level. And the bottom line is that once you factor in baseline extinctions for genera, we're looking at about a 35 to 50 fold greater loss of genera in recent years compared to the baseline level. And
recent being what, since the Industrial Revolution?
I think usually it's about, was it 1500?
1500, okay.
BC or so. Is not BC, sorry, AD, sorry. When they start looking at, when you start seeing that acceleration in genera loss. But estimates are that we've lost, for land vertebrates, 73 genera, 10 families, and 2 orders. And so they refer to this as the mutilation of the tree of life. And so this is a diagram showing, again, the background species genus loss, and then what we're seeing for.
So this is showing the number of genera that has been lost?
Yes. And again, you can start seeing an acceleration. Birds tend to be much more vulnerable than mammals, and then reptiles and amphibians, again, less so. But as I mentioned earlier, there is some concern that the data set is incomplete for reptiles and amphibians. And of course, this isn't taking into account plants or insects,
or bacteria.
Right, yeah. Right. So, this is a very serious problem. And so, when you talk about a loss of a species, that's one thing. But when you start talking about the loss of a genera or a genus or a family, now you're looking at a large collection of species that are being lost. And now you're losing branches on the tree of life.
An example of a family would be all the cats in the world.
Yeah,
so
right.
You knock out all the cats, you got no cats, period.
Yes, that's right.
Yeah.
It's one thing for a cat species, the saber-toothed tiger, to go extinct. It's another thing for felines to go extinct.
Right.
Right. So so the problem seems to be even more alarming than what we thought. So you're actually
saying that we've lost some families, not just genera?
Yeah.
Okay.
About 10 families.
10 families are gone.
Yeah. And then 2 orders. So it's a pretty serious, this is a pretty serious problem.
Talking on an order, that is serious.
Yeah. Well, and so I think regardless of your worldview, this is the type of thing that we should be paying attention to. And there are ways that we can begin to mitigate species loss, where we can maybe even, potentially reverse some of the damage we've caused to the environment and preserve, biodiversity. But it's critical, because if we dilly-dally around, the consequences could be incredibly dire.
And we don't yet have the technology to bring back these extinct species.
No. And there are people that are working on the de-extinction problem as part of work in synthetic biology and biotechnology. But right now, it's primarily being done as a novelty. And it's the only species that you can actually bring back are species in which you've got genome.
You have to have the intact DNA.
Yeah.
Right.
And there's very few species where that's actually the case. Now, for somebody that is a Christian, this problem should not only be alarming from an existential standpoint, it should be alarming theologically, because we were given the command by God to be stewards of the planet.
Right.
Right. And when you look at the 4 commands that God gave human beings as his image bearers, the first 3, to multiply and fill the earth, to subdue the earth, to exercise dominion over the creation, really have in mind promoting human flourishing, right? That we are to take advantage of the resources available to us, and we should work so that humans flourish as image bearers. And I think many conservative and evangelical Christians give deference to human flourishing, but we also are not to do that at the expense of the rest of the planet.
Yeah, if you actually look at what all you see in the book of Job and Genesis, the mandate is for our benefit and the benefit of all of Earth's life.
Yeah.
It's not either or, it's both.
Right. Well, and there's a reason for that, because whatever we do to promote the flourishing of plants and animals creates an environment where humans can flourish.
Right.
If plants and animals don't flourish, which is the concern of ecologists with this 6th great mass extinction, then human flourishing is not possible. So it's for selfish reasons we should be concerned about plants and animals flourishing. But again, it's part of the mandate that God gave us, and plants and animals are part of God's creation. This is a creation that God loves and delights in. And as stewards, we should be taking care of things that are really very important to God.
God loves it. We should love it too, right?
Right. And not to get too preachy here, but there was a Pew Foundation survey published about the relationship between religion and concern about the environment, primarily climate change, is what's being interrogated in the survey. And it turns out that conservative and evangelical Christians tend to have less concern about the environment than other religious groups or people that are non-religious. So this is a bit of an indictment, because if we indeed are image bearers who've been given a responsibility by God to care for the planet, we should be the foremost concerned about the environment, not the group that is the least concerned.
Yeah. After all, we have the Bible. We're serious about the Bible, and we should be serious about what it asks us to do.
Right. And there's a number of sociological factors that people speculate may be contributing to that. But at the end of the day, it is really, again, our obligation. The Bible also has some powerful explanatory power as to why humans are causing this kind of damage to the environment because of the fall, right? That when we were created in God's image before the fall, we were in a rightly relationship with God, a right relationship with other people, and with
our environment.
With our environment. And as a result of the fall, we became alienated from God, we're alienated from one another, and we're alienated from the world. And so instead of being stewards of the planet in a fallen state, all we're going to be able to do is cause damage to the earth. The earth is cursed because of us. It's not our sin that cursed the earth. It's our broken relationship with the creation. The creation didn't change, we changed. And in that state, we're not able to properly care for the environment. But this is where the gospel becomes, I think, important in terms of environmental care, because in the gospel, and in Christ, all things become new. And so the gospel describes a restored relationship with God, the potential to restore a relationship with others, and the potential to restore a relationship with the creation. So as Christians who are redeemed, we should be leading the response to environmental damage, not being unconcerned about it.
But doing it in a biblical way.
Right. We never want to promote extreme environmentalism, because it's always an environmentalism with an eye towards ensuring that human beings are flourishing. We don't want to compromise human flourishing at the extent of preserving the environment.
That's a good point, Fuz, because from the non-theistic perspective, they're basically saying we need to sacrifice what's beneficial for us, what's beneficial for the environment. The Bible says we don't have to choose.
Right.
There will be solutions that benefit both.
Right. Right. So anyway, not to be too preachy, but this is something that as Christians we should be concerned about, and this is also again something where the Bible has explanatory power as to how is it that human beings can cause so much damage.
I'm curious, Fuz, do you know which orders have been driven to extinction?
Off the top of my head, I don't.
Okay.
Yeah.
Because that might be a motivating factor. I mean, I wasn't aware that we had actually knocked out 2 entire orders. To me, that might give some motivation for people to say, we got to do something. It's not just the species level. It's not just the level of the genera. Families and orders are being affected.
Yeah.
And so that could be, publicized. Hey, this is what we've already lost. It might give people some motivation.
Yeah. Yeah. Yes. So
I assume you're going to write an article on this, Fuz.
I am. Yeah.
Fantastic.
I have an article that I wrote a few years ago about the 6th great mass extinction.
I remember that. Yeah.
But that one was focused on at the species level.
Right.
And really just even establishing the fact that there really is a 6th great mass extinction that is happening.
It's not something in the future. It's already happening.
Yeah.
So that when it hits the order level, you got a problem.
Yeah.
So,
yeah.
Okay, I'm looking forward to the article.
Yes.
So,
oops. Okay, and so then, Hugh, I think it's up to you.
I'm going to talk about M-Dwarfs, and you say, what are M-Dwarfs? They're stars. And these are stars that are less than half the mass of our solar system.
Okay.
But that means they're dim because the luminosity or the brightness of a star goes up with the 4th power of the mass. So if it's only half the mass of our star, the sun, that means you're only getting a 15th of its luminosity. So these stars are quite dim. But they make up 70% of all the stars in the universe. So they really dominate. So our star, the sun, is actually considered to be a massive star, right, even though we usually talk about stars that are much more massive. But the vast majority of stars are less than half the mass of our star.
And these would be third generation stars?
They can be all different generations.
Okay.
So like we've actually discovered some what we call population 3, which are the very first stars to form that are less than half the mass of the sun. For obvious reasons, stars that are that small in mass, they burn at a much less efficient rate. That explains why they're so dim. But because they're burning, their nuclear burning is at a far less efficient rate, they burn for a really long time. I mean, for example, these what we call M-Dwarf stars, they can undergo nuclear burning anywhere from 200 billion years to 2 trillion years. Compare that to our star, the sun. It's going to be done with this nuclear burning in 9 billion years. 9 billion years from the time it ignited. So right now, our star, the sun, has gone through half of its nuclear fuel. It will burn for another 4.5 billion years. But these M-stars, M-Dwarf stars, they literally burn for hundreds of billions of years. So they're going to be around a while, and explains why we can even see the very firstborn, M-Dwarf stars. I mean, they haven't gone through their nuclear fuel yet. The universe is only 14 billion years old. So we got lots to look at of all different generations. But the reason I want to talk about this, it's not just NASA, but NASA's been probably the most public one saying, this is where we're going to find habitable planets. Because number one, it's fairly easy to see planets orbiting these M-Dwarf stars. And especially since where you're going to get liquid water on a planet orbiting these stars is when the planet is orbiting quite close to the star. And the closer the planet is to the star, the easier it is to detect. So almost all the focus of let's find habitable planets has been targeting M-Dwarf stars. But I was motivated to write this piece based on several articles that have just been published in the peer-reviewed literature. And as far as I know, no one's actually done an exhaustive survey of all the papers talking about the habitability of M-Dwarf stars. So I decided to do that survey. And basically the bottom line, Fuz, is for many reasons, we need to forget about M-Dwarf stars as being candidates to planets orbiting them and which life could possibly exist. And so all the research focus, not all, but a lot of it's been targeting these M-Dwarf stars. I'm basically arguing that we need to be looking elsewhere. And so this is not a complete list, but I'm going to review for you and our audience 7 reasons out of many for why we can confidently state planets orbiting M-Dwarf stars are not going to be candidates to have life existing on them. And the one that's probably the best known amongst astrophysicists, and even I've discovered most astrophysicists don't know this, but this goes back 10 years where a number of papers are published saying for a planet to be truly habitable, it has to be simultaneously in the liquid water habitable zone and the ultraviolet habitable zone. And you're a biochemist. If you don't have ultraviolet light, there's certain crucial biochemical reactions critical for life that are not going to happen. You need some ultraviolet radiation coming into the life environment. But we all put sunscreen on in the summer months to avoid getting too much ultraviolet radiation. And so too much ultraviolet radiation, and especially ultraviolet at short wavelengths, is deadly for life. And so you need to fine-tune the quantity and the wavelength of the ultraviolet radiation coming in. But that highly depends on the mass of the star. And so what they've been able to determine is that stars more massive than the sun, you're not going to get the 2 zones overlapping. And for stars less than the sun, it's not going to happen. And the range is if the effective temperature, which is the temperature on the surface of the star, is less than 4,600 Kelvin, the ultraviolet habitable zone will never overlap the liquid water habitable zone. And where the effective temperature is more than 7,100 degrees, it's not going to happen either. So there's a sweet spot where it can happen. And our star, the sun, happens to have the optimal effective surface temperature for those two zones to possibly overlap for a planet orbiting the sun. And so our planet Earth is simultaneously orbiting in both the liquid water habitable zone and the ultraviolet habitable zone. Well, guess what? All M-Dwarf stars have a surface temperature that's cooler than 4,600 degrees. So it means none of them are candidates to have a planet orbiting them, in which you're going to have them a planet in both the liquid water habitable zone and the ultraviolet habitable zone. That's number one. Number two is that, for the planets to be in the liquid water habitable zone, they got to be a lot closer. And for M-Dwarf stars, they got to be closer than Mercury is to the sun. In fact, they got to be less than 40% the distance of Mercury is to the sun, which means they're in quite close. And I think it was back in 2016, I wrote an article that's posted on our website saying, if a planet orbiting a star has an atmosphere that's more than 1% the atmosphere of Venus, and if it's orbiting less than the distance of Venus to the sun, it's going to have an atmospheric electric field of several volts or more. For Earth, we're at about a 2-volt level. Mars is also at a 2-volt level, which is not a problem. But when you get at the 10-volt level, such as what you have for Venus, that voltage is enough to desiccate the planet. So it explains why, even though Venus formed with a lot of water, because of its atmospheric electric field, that water left the planet and went into interplanetary space. Now, obviously, it's going to be a problem for all planets orbiting M-Dwarf stars, because they're going to be orbiting much closer to the star, which means the electric field is going to be stronger. And hey, if you want to have life, you got to have some kind of an atmosphere. So if you got an atmosphere like the moon or Mars, that's not going to be adequate. And so that's a problem.
Would you also get tidal locking too?
That's number 3.
Okay.
Tidal locking. So thank you for anticipating that. And they used to think that planets orbiting M-Dwarf stars in the liquid habitable zone would either be tidally locked, like the moon is to the Earth, where you have only one hemisphere of the Earth facing the moon at all times. The only way you can see the backside is to send a spaceship around to look at it. But if we look at the planets in our solar, once you get even a few percent closer to the sun than the Earth is, tidal locking becomes a problem. Now, Venus and Mercury are not completely tidally locked, but because of the gravitational influence of the sun, where the sun's gravity on the far side of the planet is weaker than it is on the near side, you either get one of two circumstances. You get tidal locking, or you get a rotation rate that's similar to the revolutionary rate. And so what we notice with Mercury and Venus is that their days are a lot longer than our days, and their nights are a lot longer, and they're longer by weeks. So it's, but we now know that for planets orbiting M-Dwarf stars in the liquid water habitable zone, they will be completely tidally locked. And if they're tidally locked, that means one face of the planet is always facing the star, which means it's going to get blistering hot on that face, and it'll be permanently blistering hot, and it's going to be extremely cold on the dark side because it's not going to get any heat from the star. And there was speculation that maybe the twilight zone would be the place where things could be possibly habitable, where you're on that edge between the starlit side and the dark side. But what we now discovered is that when you got tidal locking, you get atmospheric transport, which basically moves all the water from the starlit side and the twilight zones into the dark side. And you don't want all your water to go to the dark side, but that's what happens. It all goes to the dark side, becomes permanently frozen, which means, yeah, the planet could have water, but all of it's going to be in the dark side, and all of it's going to be permanently frozen and unavailable to life. So that's 3. Let's go to number 4. Number 4, they're going to be exposed to powerful ultraviolet and X-ray flares. And what was new is they used to think, well, that's only a problem for the young M-Dwarf stars. When they get to be, say, 5 to 10 billion years old, the flaring activity will drop, because it's well known that for the more massive stars, the flaring activity subsides as the star gets older and older. And, like with our star, the sun, you get the least amount of flaring when it's halfway through its nuclear burning. But for M-Dwarf stars, halfway through is not 4.5 billion years, it's tens of billions of years. But they did some observations on these really old M-Dwarf stars and said the flaring rate is still way too high for that planet to be habitable. Okay, that was number 5, or number 4. Number 5 is what's called the moist greenhouse effect. And what's unique about these M-Dwarf stars is they have a long pre-main sequence phase. That's a technical term for what happens to the star before it ignites nuclear burning. So it's when the star is collapsing out of a giant molecular cloud. But as it collapses, you get gravitational energy that gets transformed into heat and light. And so what is a surprise for a lot of lay people is that, number 1, these M-Dwarf stars can spend anywhere from 10 million to 1 billion years in what's called the pre-main sequence phase. And they begin with a brightness that's 60 times brighter than when they ignite nuclear burning. And so that means they actually begin way brighter than the sun is right now. And so it means for the first 100 million, it's 100 million to 1 billion years, not 10 million, sorry, misstatements, 100 million to 1 billion years that they're in this pre-main sequence phase. But it means that the planets are being exposed to much more light and heat. And what does that do? If there's water on the planet, it evaporates the water. And water is a greenhouse gas, which traps more heat, which causes more water to be evaporated, and eventually all the liquid water is evaporated. And when you get that much water evaporated, say you're talking about enough liquid water to be suitable for life, well, if you evaporate all that water, a lot of that water is going to go up into the upper atmosphere, where it gets exposed to the radiation from the host star, which means it dissociates it into hydrogen and oxygen. And basically, the moist greenhouse effect, it's kind of an enigma because you get this very moist atmosphere, but if you make it too moist, basically lose all the water to interplanetary space. So the planet becomes desiccated. Okay, number 6, carbon dioxide outgassing. And, if you look at Venus and Mercury, there's evidence that they had volcanic activity early in their history. All planets do. And when you get volcanic activity, you get carbon dioxide being released. But that release of carbon dioxide, that's a greenhouse gas, and you wind up with a similar consequence. The only way to have the water is to have hardly any carbon dioxide outgassing. And we don't know of any model of planet formation where that would be the case, where you would get so little carbon dioxide being emitted early in this history that you wouldn't lose all the water. And number 7, probably the most catastrophic one of all, is these M-Dwarf stars during the pre-main sequence phase, and say for the first 2 or 3 billion years of their nuclear burning, they're pouring out a lot of flares, a lot of particle radiation, and the impact of this is that it sputters away not only the atmosphere, but any water that's on the surface. So the hydrosphere and the atmosphere get sputtered away. Now, the reason why that didn't happen to planet Earth, it did happen to Venus, and it happened to Mercury. Venus had a thick atmosphere, but it did lose all its water, is that Earth had a magnetosphere. That magnetic shield around the Earth basically prevented the particle radiation of the early sun from sputtering away all of our water in atmosphere. these M-Dwarf stars, even though they're a lot smaller than the sun, the radiation particles they're pouring out are far more destructive than would be the case with a star of the sun, which means you need a stronger magnetosphere. In the case of the Earth, what saved the day is we had the moon very close to the Earth at a time when it too had a strong magnetosphere, and the two magnetospheres coupled together, giving Earth a strong enough magnetosphere that prevented our planet from losing its atmosphere and its water.
So like with the moon then, it kind of we kind of got 2 for 1, because the collision that formed the moon caused the core of Theia to fuse with the core of the Earth, creating a liquid core that set up this magnetosphere. And then the moon on top of that had its own magnetosphere.
Well, the merging of Theia with the proto-Earth resulted in both the Earth and the moon having a hot liquid iron core.
Okay.
And because they were so close together, the tidal forces that they exerted on one another circulated that liquid iron in the core, which established a magnetic field, which established a magnetosphere. And because of how close together they were, the two magnetospheres merged to make a coupled magnetosphere. And this is up on our website. I wrote 2 articles on it. It's in the book, Design to the Core, basically saying nothing less than that will save a planet like the Earth from losing all of its water and atmosphere. And it's far more problematic when you're orbiting an M-Dwarf star, because now you're closer to the star, which means you're getting much more intense radiation. And the planet, the star, is far more active than our star of the sun. And again, we don't know of any possible scenario which would provide a planet orbiting an M-Dwarf star with a magnetosphere powerful enough to save the day. Now, this is a review of what I covered with Jeff, but I'll be very quick with it. The next slide basically shows a scenario, no, one after this. That's just basically, this one here, because people said, okay, this is bad news for rocky planets, but maybe we can save the day with a Neptune planet, because maybe with these M-Dwarf stars, Neptune planets form far away and they migrate inward. And indeed, we have found several hundred of these Neptune planets orbiting M-Dwarf stars. So we know they exist. And the thinking is, well, what if they have a thin hydrogen atmosphere overlaying a really thick ocean? Maybe then we can have life in the ocean. But what it overlooks is even those kinds of planets aren't going to save the day. That hydrogen atmosphere is also going to be subject to being eroded by the M-Dwarf star. But you got a problem with all that water. You got so much water on the planet. So instead of an ocean being 4 kilometers deep, which is the average for Earth's oceans, you're now looking at oceans that are hundreds and even thousands of kilometers deep. And when you get oceans that deep, not only does ice form on the surface, ice forms at the bottom. And no matter what the temperature of the liquid water, it's guaranteed you're going to get ice at the bottom. The pressure is going to be so great, it forms ice at the bottom of that ocean. And that ice layer will be permanent, which means you've got a permanent barrier between the rocky material of the planet and the liquid water. And you're a biochemist. If that's the situation, you can forget about any origin of life scenario or the survival of any life that happens to get there, because they're not going to have the chemical resources that they need. And so even that outlier candidate is not going to work. Bottom line, I think we need to take M-Dwarf stars off the list as a place to look for planets that have life on it. We really need to be focusing on Earth twins, planets that are just like planet Earth. And, I'm open to the idea that God created another planet in which life is possible. But we've been scouring our galaxy trying to find an Earth twin. And we've found about half a dozen what we call Earth analogs. But by far and away, the closest analog to the Earth that we found other than our own planet Earth is Venus. Venus turns out to be, by a long shot, the best Earth analog that we found beyond our planet. And no one would consider Venus to be a candidate for life. I'm not saying that such a planet doesn't exist, but if we're really serious about trying to find a habitable planet, that's where we need to put our focus. Look for stars that are just like our star to the sun, with a planet orbiting it that's just like our planet Earth. And that, in my opinion, is the best place to target our research. And you say, well, what if the answer is no? Well, in my opinion, a no answer is just as good as a yes answer. I mean, that's how science works.
Right.
We try to figure, okay, is the answer yes or the answer is no? And we consider both results to be valuable. And I think this is, either way, is going to yield for us additional evidences that support the idea that Earth and the sun indeed have been designed by an intelligent being to make possible life on our planet. And if he did it twice or 3 times, well, that's great. If he did it only once, that's great. But by targeting our research on solar twins and Earth twins, I think we're going to be able to be more successful in coming up with useful research results. And I think it's going to really strengthen our faith in what the Bible and the Christian faith have to say.
Yeah. Fascinating stuff, Hugh.
Okay. All right. Well, thank you for joining us today on Stars, Cells, and God. Join the discussion in the comments below. Remember to like this video and to subscribe for more content. Yeah, please become a subscriber on our Reasons to Believe YouTube channel. It's free, and you'll be alerted to all the additional episodes of Stars, Cells, and God, which release each Wednesday and are available on YouTube and on your favorite podcast app. Be sure to share this video with a friend, and remember, the more we learn about science, the more reasons we have to believe in Jesus Christ as Creator, Lord, and Savior. Thank you.